Hello, today we have this problem. If this series converges, and if the sequence Bn is monotonic and bounded, have to prove that the sum of product A and Bn as series is supposed to converge. So first of all, let's write down that Bn is less than some beta. That's what we know for sure. Okay. Now with this established, well, we can also include this fact. Beta is greater than 0. Although it's not really necessary. Bn is monotonic and bounded. Bn plus 1. Okay, no, let's ignore that for a second. As monotonic and bounded, prove that this sum converges. Well, let's take An Bn. And this would be less than An beta. So the sum A and Bn with k starting from some m up to n, and let's replace n for k in the index, is gonna be less than the same sum, except here we have ak and here we have beta. Okay, except that will be true only if we take the absolute value here. Alright. Now, with this established, it is evident that series AKBK. Okay, let's use n instead here. A and Bn with absolute value here is gonna converge. Now what we're gonna do is we're gonna show that this implies that A and Bn without the absolute value converges. So suppose we have some new sequence xn and yn, and let's say that x0 equals x1 equals y1 equals 0. Let's say that absolute value of yn is always greater than or equal to absolute value of xn. And now suppose we have some number L. Let's say actually, okay, let's, instead of L, let's take let's say that yn plus 1 is gonna be equal to the absolute value of yn plus an plus 1 bn plus 1, and we take the absolute value here again, equals this. Okay, yn is gonna be always positive, we don't need the absolute value here, so for xn plus 1 we can just say xn plus an plus 1 bn plus 1. Now the issue here is that we need to prove the statement for general n. It's true for 0, not 0, 1 as n, but we don't know for the other cases, so let's work on that. First of all, let's work on this part. So the absolute value of x and plus 1, can write it down as xn plus an plus 1 times bn plus 1. Okay, and then it's going to be less than or equal to value of xn plus the absolute value of an plus 1 bn plus 1. Now this over here is just xn plus 1, and we take the absolute value. Here we have less than or equal to now so essentially what we have here is we can say y n plus a n plus 1 times bn plus 1 plus the difference x n minus yn. We have here is xn plus 1 is less than or equal to yn plus 1, the absolute value, plus the value of xn minus the absolute value of yn, and that's going to be less than absolute value of yn plus 1. So we have proven inductively this will be always the case, and it is sufficient to say that it's going to be greater than a and bn. By the absolute value. And this is gonna be equal to plus minus a and bn. So a and bn is gonna converge. That's what we know for sure. In a way. That's it for today, yeah? Not for rigorous, because again, using a limit notation is really annoying when it comes to literal pains and mouse. So that's it for today, bye.